Now we're going to jump into quadratics in standard form. So if you see a function that looks like this, ax squared plus bx plus c, there's our standard form equation. And the problem with that is it doesn't automatically show you where the vertex is. So we need a way to find the vertex without a calculator and without graphing it. Since this is not in vertex form, we'll need to find the vertex, ordered pair HK. We first write down the values of A, B, and C, and then find H, which is our x coordinate of the vertex. We do that with this formula. It says negative b over 2a. That's something that you're going to have to memorize. That will give us the x coordinate, but then we need our y coordinate. We do that by plugging that x value in to the function to get the y value. Once we have that, we can find the whole vertex. So let's do that in this first example. Example 1 says find the maximum or minimum value vertex of this function. We have x squared plus 4x, but there's no other term. There's no constant term. So I'm going to put plus 0 because that's what's there. Now when I look at it, a is the number in front of x squared, so that would be a 1. B is the number in front of x, so that's 4, and c is 0. This quadratic is in standard form. In that case, we're going to need x equals negative b over 2a to get the x coordinate. So if I did that, let's do it down here, x equals negative b over 2a would be negative 8, not negative 8, negative 4, sorry, over 2 times 1. And then we can plug that in our calculator if we need to, but negative 4 divided by 2 is just negative 2. The x coordinate is negative 2. That also tells us our axis of symmetry. So x equals negative 2 is the axis of symmetry. We need the y coordinate, which means I need to plug that in. So you're going to see this notation, find the value of f of negative b over 2a. That's just find the value of where x is negative 2, and then get the y value. So f of negative 2 would say negative 2 squared plus 4 times negative 2 plus 0. You can put that in your calculator if you need to, but you want to make sure when you do put things in your calculator, you're putting this in parentheses, because that negative 2 needs to be, the whole thing is squared, plus 4 times negative 2, you can do plus 0, but we get negative 4 as our output. That means that our vertex is negative 2, negative 4. We have our x coordinate we already found, then we just input the negative 2 to get an output of negative 4. I'm going to do this increasing, decreasing here in a second because we just got enough information to now put it in vertex form. So our vertex form would say y equals a is 1, x minus h, so minus h would say negative 2, so x minus a negative 2 squared plus k is negative 4. You're oftentimes not going to see it written that way because this minus and negative looks weird. Let's just simplify it down. That becomes x plus 2 squared minus 4. So we found our vertex, we put it in vertex form. That's already enough information to give us this increasing, decreasing, but we can also kind of make a sketch. It went backwards 2 and down 4. And it's shaped this way. So it would look something like that. We want to know when it's increasing, which would be the right side of the vertex. So from negative 2 to infinity. And then it's decreasing on the left side. So that would be negative infinity all the way to negative 2. And it looks like that's everything we needed for that part. But when we get to the second page, it says now we have two forms of that same quadratic function. We've got the general form, and that was what we started out with, y equals x squared plus 4x plus 0. But then we also found our transformation form, or our vertex form, which was y equals x plus 2 squared minus 4. So both of those formats can be helpful in their own way. With the vertex form, we see the vertex nicely. With standard form, it actually makes it easier to find our y-intercepts and our x-intercepts. So we're going to use standard form for those. But we could use either form to find the y-intercept. So let's just remember that part. It doesn't matter. But I'm going to use the standard form. So the y-intercept is the value of y when x is 0. If I plug 0 in, we get 0 squared 0, 4 times 0 is 0, plus 0 is 0. That gives me a y-intercept of 0, 0. Now we need the x-intercepts. It does say use the general form. If it's in vertex form, we would multiply it out, and then we can find the x-intercepts. These are also known as the zeros of the function. You may have heard us talk about it that way before. To find the zeros, or the x-intercepts, we want to solve this equation. When does the function equal 0? So x squared plus 4x equals 0. We would do that, because it's a quadratic equation, by factoring or by the quadratic formula. And so the first rule of factoring is to look for a GCF. This has a GCF of x in this case. A GCF is that greatest common factor. So if there's some factoring things you want to review, there's some other videos on that. But I'm going to factor out an x from each term. So x squared divided by x would leave me with just 1x, and 4x divided by x would be plus 4. If you distributed that back through, x times x would be x squared, x times 4, 4x. So we know we've done it right, but we want to use the zero product property. That's technically what we're going, the property we're using. The zero product property to set each factor equal to 0. So if I set each one here, x equals 0 and x plus 4 equals 0. This first one doesn't have anything to do because x is already solved, but the next one I need to subtract 4 to give me negative 4. So the x-intercepts, if we write them out, would say 0, 0 and negative 4, 0. That's enough to graph everything that we need. I'm going to put our vertex in that we found. It was negative 2, negative 4. We have a vertex, our y-intercept of 0, 0. That's also one of the x-intercepts. The other x-intercept is negative 4, 0. So we can put that point in there. And then if you follow the format, let me zoom in a little bit. Because we know this did not have a vertical stretch, it was just a 1 here, it follows the same parent function format. So I'm going to go from the vertex out 1, up 1. Out 1, up 1 from the vertex. We can see we also go out 2, up 4, but that's where our x-intercepts are located. We can go out 3, up 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And that gives us most of the graph here. All right, let's jump to example 2. We have a new function, 2x squared plus 8x minus 10. We need it in vertex form. So let's remind ourselves, what is vertex form? If you write it out multiple times, every single time you're doing this, it's really going to help you out. You'll start to memorize it that way. So y equals ax x minus h squared plus k. There's our vertex form. To find our vertex, we first need to do x equals negative b over 2a. So same thing, just keep writing out the formula when you're doing the problem, and that will help you memorize it and understand it a little bit better. That would be negative 8 in this case over 2 times 2. So a was 2, b is 8, and c is negative 10. If I evaluated this, so negative 8 over 2 times 2 would be negative 8 over 4, which is just negative 2. There's our x value, but then we need our y value, so let's find f of negative 2. I would say 2 times negative 2 squared plus 8 times negative 2 minus 10. Put that in your calculator so that you've got 2 times negative 2 squared plus 8 times negative 2, put those in parentheses, minus 10, gives me an output of negative 18. F of negative 2 is negative 18. That's our vertex. Negative 2, negative 18. Vertex form would say y equals a, but a was 2. X minus h. So x minus negative 2 becomes x plus 2 squared plus k, so plus negative 18 is just minus 18. And that's our vertex form. That is helpful when we're trying to graph this. We want to find the maximum or minimum value of the function and where it occurs. So based off the vertex, we have a maximum or minimum of negative 18. We just need to decide what direction is this opening. We have a positive a value, so it opens up. That tells me there's a minimum, so we're having a minimum of negative 18, and it occurs when x is equal to negative 2. So if we're asked the question, what is the minimum is negative 18. When does that occur is when x is negative 2. I'm going to go ahead and graph what we can and then jump to these in here in a minute. So if I start with the vertex, one thing I want to notice is that our graph is counting by 2's on the x-axis and 5's on the y's. Now it's going to be hard to see because this didn't print out perfectly, but if you've got a copy of the notes, it should make it a little bit easier. I'm going to go to negative 2 and negative 18. Now here's negative 15. So 16, 17, 18. We'll be right there. Our function had a vertical stretch of 2. So I would go out 1, up 2. But when you look at the x-axis, this makes it a little bit trickier. Here's 2, and that's 4. There are 1, 2, 3, 4 lines in between. So this middle one is 1. This middle one is 3. So if it's helpful for you to find these values, go ahead and label them. And we can go from there, but I'm going to go out 1, which is at this negative 1, and up 2. Out 1, up 2. We would go out 2, up 4, but that 4 has been stretched by a factor of 2, so that 4 becomes 8. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, and put my point. Out 2 and up 8 makes that symmetric. I would go out 3 and then up 9 normally, but that 9 has been stretched by a factor of 2, so it becomes 18. So I'm going to go out 3, up 18. Puts me there. And on this side, there. That's enough to graph this whole thing. So I like it when it's in transformation form or vertex form because it is a lot easier to visualize. But we can find all these key information pieces without it being in vertex form. So let me zoom back out. And we're going to focus on the increasing and decreasing here. Our increasing side is to the right. That's going to be all the x values to the right of -2. So there's our axis of symmetry right here at -2. And anything to the right is increasing. So from -2 to infinity. Our decrease section is from -infinity to -2. And then it asks about where are the horizontal intercepts or our x-intercepts. So sometimes you might see it written as horizontal intercepts because we're looking at the horizontal axis. But this would say, when does the function equal 0? So 2x squared plus 8x minus 10 equals 0. Remember, we always look for a GCF first. If I look at 2x squared, 8x, and -10, something I see automatically is that those are all even numbers, so that means 2 goes into everything. And that's the greatest common factor for these because 2 can only be divided by 2. So I'm going to factor out a 2 from every single piece. That leaves me with x squared plus 4x minus 5. And then we continue factoring if we can. So I'm going to take this quadratic here and turn it into our two binomials. X squared came from multiplying x times x. I look at my -5, and the only way to get a 5 is from 5 and 1. So I know I would have 5 and 1, but I need a positive 4. That would be a positive 5 and a -1. We can use the zero product property to set each factor equal to 0. And that would say, in this case, x plus 5 equals 0, and x minus 1 equals 0. 2 is a factor in this quadratic, but 2 can't be 0 because 2 is just 2. It's a number. We can find when x plus 5 equals 0. That would be when x is -5. And then x equals 1 is our other 0. So our x-intercepts, when we write them out as coordinates, would be -5, 0, and 1, 0. If you notice on the graph, that's where we found these already. The last part here is finding our y-intercept. Our y-intercept, let's just put it down here, is what is the y value when x is 0? So 2 times 0 squared plus 8 times 0 minus 10. You work that out, you should get a -10. Hopefully you'll see that it keeps coming out as the constant term when it's in standard form. So it's a nice way to see our x and y-intercepts with standard form. There's our y-intercept 0, -10. And then we've already graphed it. All right, in the next video, we'll stop it there, but the next one we'll go through example 3.